Well, this is a shout out to my Section 2 calculus. Allison came to me today asking a question, and I realized that in the excitement of having a story time during double black, we didn't do a couple problems in class that I did in all my other classes. So as a result, I'm going to do a couple of the odd problems from last night's worksheet just to clarify, and all my other sections will benefit from this if you watch the video. So number 23. We are asked to find the limit as x approaches -1 of this piecewise function. Now, when it's a piecewise function, I need to look, it's -1. I need to look from the left and the right to determine if the limit from the left is equivalent to the limit from the right. So let's first examine the limit as x approaches -1 from the left. Okay, so when I look from the left, I'm going to look at the piece that is all the values less than 1. So that would be this piece. So from the left, I'm going to substitute the value -1 into that piece. So that means the limit as I approach -1 from the left is -2. Now I'm going to proceed and do the same thing, but this time I'm going to find the limit as I approach -1 from the right of the function f of x. So now, since I want the values greater than -1, I'm now going to look at this piece because x is greater or equal to -1. So I'm going to substitute the value -1 into this expression. So I have a -1 cubed minus 1. Oops, I don't know why I put -3. Oh, I haven't used this app in a long time. How do I do erase? Oh, there it is. There we go. Okay, back at you. So -1 minus 1. Yes, so -1 cubed is -1 minus 1 equals -2. Look at what we notice here. The limit as x approaches -1 from the left is equivalent to the limit as x approaches -1 from the right. So therefore, the limit does exist. So the answer then would be -1. Okay. So that is number 23. Now, do you see what I just did wrong? The answer isn't -1. Look, the value is -2. The value is -2. So I must have just mixed up my number I'm approaching. So this answer should be -2 because that is the value they both approach. Okay, moving right along, let's do problem number 25. Okay, 25, we have the limit as x approaches 0 of the square root of x plus 4 minus 2 all over x. Okay, so we're going to approach 0. So since it's a constant, first step is substitute 0 into the expression. Well, I'm going to get the square root of 4 minus 2 all over 0, which we end up with 0 over 0. Woo! We love me some 0 minus 0 over 0. That's indeterminate form. So that means we need to do a little bit more work. Well, the first step would be to factor. But when I look at this expression here, I notice it's not a factorable expression. So the next step is to multiply by the conjugate. Now today in class, we said that a conjugate is when you have a binomial. So the binomial in this expression is the square root of x plus 4 minus 2. And the terms stay the same, but instead of it being minus 2, it's now going to be plus 2. So what I do is I multiply the numerator by the conjugate. And if I multiply the numerator by the conjugate, then I must multiply the denominator by the conjugate. Now my goal here is that by doing this procedure, I will mix up the expression in such a way and simplify it and rewrite it so that when I substitute the value 0 in, I'll actually get a value. Okay, now we're going to multiply the two binomials, and we know that when we multiply the square root of x plus 4 times the square root of x plus 4, we get x plus 4. And then when we multiply the outer and the inner term, they're going to reduce out because it's a positive 2 square root of x plus 4 and a negative 2 square root of x plus 4. And last of all, we have minus 4. And then that's all over x times a quantity, the square root of x plus 4 plus 2. I'm seeing some things here that will reduce out. For example, 4 minus 4 is going to give me 0. So now I have the limit as x approaches 0. Notice I keep writing limit notation because I have not evaluated the limit yet. So I have to keep that notation there, like the capital of a sentence. Okay, now I see that the x is reduced. So notice how I've rewritten this expression, and I have 1 over the square root of x plus 4 plus 2. Well, now let's substitute 0 in and see if we get a value for this limit. So I'm going to have 1 over the square root of 4 plus 2. So it's 1 over 2 plus 2. Oh, so actually the limit is 1/4. So from the left to the right, the function will approach 1/4. Okay, I'll do more with you. I'll do one more with you, and that will be number 27. Now, number 27, you are given a piecewise function, and we have in the first piece x squared minus 49 all over x minus 7, where x cannot equal 7. In the second piece, we have k squared minus 2, where x equals 7. Okay, and we're asked to find the value of k such that the limit as x approaches 7 of f of x will equal the value at 7. Okay, interesting. Well, let's first find the limit as x approaches 7. Okay, so let's check that out. Well, we know that if we look at it, the limit where x cannot equal 7, of the function, but you're saying, but wait, Ms. Kleiber, x cannot equal 7. But if I'm looking to see how it approaches 7, because that's what limit means, then I'm going to look at all the numbers that are not 7, like to the right and the left. And so if I do that, I'm going to get 49 minus 49, because 7 squared is 49, all over 7 minus 7. Aha, indeterminate form. Well, I can see right away that this expression can be factored. So let's factor this expression, and we're going to get x plus 7 times the quantity x minus 7 all over x minus 7. We see that those reduce out. Now if I substitute 7, 7 plus 7 is 14. So when x does not equal 7, but it equals every other value, the function is approaching 14. Okay, now what happens when we're looking at the limit as x equals 7? Or another way of saying that is, what is the value at 7? Okay, so the value of 7 is going to be k squared minus 2. Okay, so we have these two values here, but what did the original question say? It said, when will the limit as x approaches 7 of f of x, which we know to be 14, when will that equal f of 7? Well, we know f of 7 to be k squared minus 2. So now let's solve for k. Add 2, 16, k squared. So then we know k squared will be, will be plus or minus 4. So there you have it, folks. I did 3 of the problems for homework. Now you finish the rest. And I'll see you guys on Tuesday.